Okay, so this is your review for the exam that'll be on Friday, September the 27th. It'll be your second test in AP Chemistry. So what we're going to do is balance these equations, and we're going to put the elements down here, nitrogen and hydrogen. Okay? And what we have to do is count the atoms on each side. So over here I have two nitrogen and 4 hydrogen. Over on this side I have 1 nitrogen plus 2 more is 3. And I have 3 hydrogen. Okay, so you can start with balancing whichever one you would like, but I strongly recommend you avoid anything that appears more than once on the same side of the arrow. So here we have nitrogen and nitrogen again. So I would start with hydrogen. All right, so 3 doesn't go into 4 and 4 doesn't go into 3. So we need to find the smallest number that they will both go into, the least common multiple, lowest common multiple, and that would be 12. One way to do that is, if you're not sure, is just multiply them together. That'll at least give you a common multiple. It may not be the lowest. And if it's not the lowest, it's okay. You can still work with it. You're just going to have to do some reducing later on. But anyway, 4 times 3 is 12. So we're going to go for 12. So 3 times 4 here. So I have 4 times 3, so that gives me 12 hydrogens. And over here I have 4 hydrogens times 3. Okay, 4 times 3, and that's 12 hydrogens. So now let's count nitrogens. Let's see what we've got. We've got 3 times 2 is 6, and here we have 4 times 1 is 4, plus 2 more is 6. So for nitrogens, we end up with 6 on this side, and we end up with 6 on this side, and hydrogens, we end up with 12 on this side, and 12 on this side, and everything is in balance. So our answer is 3, 4, and then I'll put a 1 coefficient right there. All right, let's go on to the next one. So we're going to write down our elements, Fe, S, H, and Cl. All right, so let's count elements. So we have Fe, 1 Fe on both sides, that's iron. We have sulfur on this side, and we have 1 sulfur on this side. Chlorine, we have 1 on this side, and we have 2 on this side. And hydrogen, we have 1 on this side and 2 on this side. Okay, so you can't start balancing something that's already in balance, so iron and sulfur are not available, but they may end up out of balance as we proceed, and then we have to get them back in balance. So let's go ahead and start with hydrogen. That's as good as anything. So I have 2 on this side. That means I have to have 2 on this side, so I put a 2 right there. Okay, and now I have 2 chlorines and 2 chlorines here, and I already had 2 chlorines here. So what you can do is, if you want, you can keep track as you go along like that. Some people like to do that. I usually don't, but you can. So let's see if everything's in balance. 1 iron, sulfur, sulfur, 2 hydrogens, 2 hydrogens, 2 chlorines, 2 chlorines. So that's your answer. So it's 1, 2. I usually write the 2 or the coefficients up above like that, because I don't know if that's going to be my final number. But now that I know it is, I'm going to put it there, and then I have a 1 there and a 1 there, and that takes care of that reaction. Okay, this reaction is challenging because you've got to count your atoms carefully here. So, and there's a lot of them. So we're going to start off. CO is not carbon dioxide or carbon monoxide. It's cobalt. It's a lowercase o. That means it's part of the C. It's the same element, so it's cobalt. Okay, and then we have N here. We have O here. And then we have H and S. All right, so we have 1 cobalt on this side, and we have 2 on this side. Now we'll go to nitrogen. Okay, so what this subscript outside of the parentheses does is it distributes, just like in a math equation. So it's going to be 3 times 1 is 3 nitrogens, and 3 times 3 is going to be 9 oxygens there. Okay, so over here, this 2 is going to distribute, so you have 2 nitrogens there, and you have 8 hydrogens there. So let's go ahead and let's take care of the left side first. So the oxygens are going to be 3 times 3 is 9. And let's just do the sulfur. That's 1. That's real easy. And the hydrogen is 2 times 4 is 8. And now the nitrogen is going to be 3 times 1 is 3. Then you have to go over here, and you have 2 times 1 is 2. So you have 2 over here, 3 over here. That gives you 5 nitrogens. All right, on this side we have 2 cobalts. We already had that. We have 3 sulfurs. We have 2 nitrogens. That's a little tricky. They're in 2 different locations, and they're each a subscript of 1, so there's 2 of those. Okay, oxygen on this side we have 3, and hydrogen we have 4 hydrogens right here. Okay, so we've counted all of our atoms before balancing. Now what you do is you want to look for the easiest thing to balance, and that would be cobalt. Again, you want to stay away from anything that appears more than once on the same side. Now, in this case, these 2 nitrogens are part of the same compound. I wouldn't count that as being more than once. They're within the same compound. But over here, you have a nitrogen in this compound, you have another one in this one. So I would stay away from nitrogen until the very last. Okay. So cobalt only appears once on each, one time on each side. There's 2 of them here, 1 of them here. So I'm going to go ahead and put a 2 subscript right there. All right. Now, what do we go to next? Let's try sulfur. That's another easy one. There's 1 of them here and 3 of them there. So I'm going to put a 3 here. I'm going to draw a line so I don't get confused here. So there's a 3 right there. Okay. So we got sulfur and cobalt in balance. Now let's look at, we got this one in balance and this one, and we want to stay away from nitrogen for right now. So we're looking at oxygen and hydrogen. So let's look at oxygen. Now watch what happens here. You have 3 here and a 3 in there. So that's 3 times 3 is 9. But this 2 applies to everything. So the 3 only applies to multiplying the nitrogen and the oxygen because they're in the parentheses there. But the 2 multiplies everything by 2. So for oxygen, we have 3 times 3 is 9, times 2 is 18. So that's 18 right there. Okay, and over on this side, we still have the 3. So we want to get this to be 18. So 3 times what would give us 18? That would be a 6. So 3 times 6 is 18. So we end up with 18 on this side, 18 on that side. Okay, and then what about the other thing, hydrogen? Well, we have 6 times 4 is 24 hydrogens. That's a lot. Over here, we have 2 times 4 is 8, and 8 times 3 is 24. So our hydrogens are also in balance. They're 24 on both sides. So let's see. I think everything's in balance then. We turned the sulfur into a 3 already. Well, now we got to see what happens with nitrogen. Okay, we're going to hope that nitrogen is already in balance. And that's often what happens when you leave the hardest one for last. So we have 6 nitrogens here. Watch out here. 6 times 1 is 6. 6 times 1 is 6. Okay, each of these are 1 nitrogen. You multiply each of them by 6, not just one time, but both times. So 6 plus 6 is 12. And if we come over here, we have 2 times 3 is 6. And over here we have this 3 times 1 is 3 times 2 is 6. So we have 6 nitrogens here and 6 nitrogens here. So that puts us at 12 on both sides. So let's just double count everything. So, and check them off. So 2 cobalts, check. Nitrogens, we just said that we have 6 here and 6 here is 12. And over here is 6 times 1, 6 times 1 is 12. So nitrogen's good. Oxygen is 9 times 2 is 18. That's good. And 3 times 6 is 18. So oxygen is good. And hydrogen is 2 times 4 is 8, times 3 is 24. And 6 times 4 is 24. So hydrogen is good. And finally, sulfur is 3 there. And 3 times 1 is 3. So that's good. So everything's good. So the answer is 2, 3, 1, and 6. 2, 3, 1, 6. All right, let's move on to the next one. And we're going to write down our elements, COH. All right, let's count. We have 1 on this side. We have 6 on this side. Oxygens are all over the place. We got 2 here plus 1 more there is 3. And we have 6 here plus 2 there is 8. And we've got H2 here, so that's 2. And we've got 12 there. Okay, so what's the simplest thing to balance there? Well, first of all, what do you stay away from? Stay away from oxygen for 2 reasons. For either one of these reasons, you stay away. It's a pure element. Stay away from pure elements until the end. The other thing is it appears in more than one location on both sides of the equation. So for that reason as well, you would stay away. So oxygen comes last. The easiest one between carbon and hydrogen to balance is clearly carbon. So there's 6 carbons there, so I'm going to put a 6 here. Now normally I'd want to take this 6 and multiply by 2 and get 12 and balance over here, but we want to stay away from the oxygen. So I'm going to do the hydrogen next. I have 12 hydrogens here. I have 2 here. What do I need to put out front to get it to be 12? I need a 6. 6 times 2 is 12. So hydrogens are in balance, carbon's in balance. Now, what's nice about this is it's kind of a floater. We find out what we need to get our oxygen in balance, and then we put that coefficient here. So watch what happens. 6 times 2 is 12, and 6 times 1 is 6. So on the left side, it's 12 plus 6 is 18. Over here, again, let me draw a line here because we're getting a little crowded here. Okay, over here I have just 6. And I have to get up to 18. So how do what do I do to this so I get up to 18? 6 plus what number gives me to 18? That would be 12. And what do I have to multiply this by to get 12? And that would be 6. So the answer here is 6616. Okay? And if you count them all out, you will see that they do balance out. All right? This next one looks very simple, but it actually turns out to be a little bit trickier than it looks. Okay, so what do I have here? I have Na, I have H, and I have O. All right, so sodium. The sodium's 1 and 1. They're already balanced, but remember, it doesn't mean they're going to stay that way. You might throw them out of balance for a while, and you will in this case. Okay, next is hydrogen. So we have 2 hydrogens here, and we have 1 hydrogen here and 2 more there, so that's 3. Finally, oxygen. We have 1 there and 1 there. So 2 of the 3 are in balance, but they're not going to stay that way. At least at the beginning. Okay, so the only thing we have to balance, you can't balance things that are already in balance, so you have to balance these 2, the hydrogen, and they don't divide into each other evenly, so you have to find the least common multiple. So they both go into 6, okay? If you weren't sure that just 2 times 3 is 6, just go ahead and use the number 6. Okay, so here we go. So if hydrogen here is a 2, I want it to be a 6, I have to put a 3 there. I take that back. Let's go to this side. I have 2 here, and I need it to be a 6, so I put a 3 here. So 3 times 2 is 6. Now this side's a little trickier. I want to get it to be a 6. If I do 2 times 2, I'll have 4 here, plus 1 more is 5. If I do 3 times 2, I'll have 6 here, plus 1 more is 7. In other words, I keep missing 6. So what I want to do is, let's leave this one. That's a 2. Let's get this one up to 4. So let's put a 4 right here. So 4 times 1 is 4, 1 times 2 is 2, 4 plus 2 is 6. So now we do have 6 hydrogens on both sides. All right, what we did, however, is, so our hydrogens are in balance, but we threw our oxygens out of balance. Now we have 4 oxygens here and 3 oxygens here. So the only way we're going to get them back in balance, since 3 does not go into 4 or 4 into 3, we're going to have to scratch that and turn this into 12. And we're going to have to scratch this and turn this into 12. Now our oxygen is 12 oxygens there and 12 oxygens there. Sodium, I've got 12 here, but I only have 1 here, so I'm going to make that a 12. So now I have 12 sodiums, I have 12 oxygens, and now let's look at hydrogen. Over on this side, I have 2 times 12 is 24. Over here, I have 12 times 1 is 12. So I need 12 more, 12 plus something to give me 24, so that's going to be 12 plus 12. So what do I do to make this a 12? I put a 6 there. So what I have is 12, 12, 12, 6, but you reduce that down just like a fraction as far as you can. So this one's going to be 12 divided by 6 is 2, 12 divided by 6 is 2, 12 divided by 6 is 2, and 6 divided by 6 is 1. So it's going to be 2, 2, 2, 1. And so that takes care of the balancing. Okay, so now we're going to do the stoichiometry problems. And you have an equation. Notice I didn't draw the boxes. If you feel like you need the boxes, I would memorize this sequence of what I put when I put them down and just memorize it, okay? I'd write it out 5 times, 10 times. When you get up tomorrow, I'd write it out again. And that is, on the top we have liters. And then the next line right here is going to be moles to liters. Okay, and then now if you want to draw the boxes, go ahead. You maybe just want to write those words, you know that what goes there. And remember, moles per liters only applies to gases. So I have two of these three substances here are gases. So I can write 1 mole equals 22.4 liters, and 1 mole equals 22.4 liters. Okay, I'm not going to write it here because this is a liquid. It doesn't apply to that. So whatever number of liters either I want to start with or I need to find would go in these boxes up here. Down here is moles. And I'm going to draw a box here, box here, box here. And then I'm going to draw my dashed line around this. This is the world of the chemical equation. It has to be expressed in moles. Chemical equations don't understand grams or liters. Okay, so to get into moles from liters, I use these conversions right here. These two. So here to here gives you there. Using that conversion gets you here. Now, down here, I'm going to do my molar mass conversions. Okay, if that term is still strange to you, you got to kind of come to grips with that, okay? A molar mass is 1 mole equals some number of grams, and you figure that out from the periodic table. So molar mass. So for N2H4, it's going to be, let me erase these lines here, it's going to be 2 times 14.01, which is going to be 28.02, plus 4.04, so that's going to be 32.06. So the molar mass is 1 mole of this compound equals 32.06 grams. Okay. For the next one, ammonia. It's going to be 14.01 plus 3.03, and that's going to give you 17.04. So 1 mole of ammonia equals 17.04 grams. Okay, and N2 is going to be 2 times 14.02, and so that's going to be 1 mole equals 28.02 grams. All right? Okay. So now one more thing is grams. If you're given grams, or if you're trying to find grams, it goes in this box, these boxes down here in the grams row. So you don't need to draw a lot of boxes to practice this. I would just write liters, moles per liter, moles, molar mass, grams. Just be sure you know that sequence that you can write this. I will give you enough space on the test to draw these boxes, but I'm not going to give them to you. You need to know those as part of the test. Okay, here we go. So, first question is, how many grams of N2? So, grams of N2 is right here. Okay, it's in the grams row and it's under N2. It's produced from 10.02 moles of N2H4. So there's N2H4 moles right there. It's in the moles row. It's under N2H4. So it's 10.2. So how do I get from my known to my unknown? You can only go sideways inside the dashed line, inside the chemical equation. So I go from moles of this to moles of nitrogen gas, and then from moles of nitrogen gas using the molar mass conversion, it gives me my grams of nitrogen gas, which is what I'm looking for. So way over here on the right, I'm going to write grams of N2. And way over here on the left, I'm going to write 10.2 moles of N2H4. Okay, and you saw that I had 1, 2 conversions. Again, one to go from here to here, one to go from there to there. So I'm going to draw 2 boxes. Okay, so to get this to go away, I need moles of N2H4 on the bottom. So what do we have to work with? First of all, what we've got to do, and this is a mistake that some of you made in class, you didn't balance the equation. You've got to balance equations in chemistry, okay? So let's go and do that. And it's actually been done for us. It was done in the very first problem on this problem set. And it is 3, 4, and 1. Okay, so 3, 4, and 1 is your balanced equation. Yes, you can never work with an unbalanced equation. All right? So now what we got to do is we've got a molar to moles conversion. 3 moles of this over 1 mole of this. So the way you could write that, I'll just do that off to the side here, is 3 moles of N2H4 over 1 mole of N2. Or, I'll write the or up above, or 1 mole of N2 over 3 moles of N2H4. Okay, so which one do you want to use? Well, we need moles of N2H4 on the bottom. That means we need this one. Okay, so I'm going to put 3 moles N2H4, and on top I have 1 mole of N2. Okay, I cancel moles of N2H4. Now I need moles of N2 on the bottom, and I know based on this being the last conversion that I need grams of N2 on the top. I could go ahead and write that right now. Grams of N2, moles of N2. So what relates those two? And that's the molar mass conversion. So let me write that over here. 1 mole of N2 over 28.02 grams of N2, or 28.02 grams of N2 over 1 mole of N2. Okay, which one do I want? Well, I need moles of N2 on the bottom. Yeah, I have that already. So I need that one, and I need the one with grams on top. So the 28.2 goes here, 28.02 goes here, and the 1 mole goes on the bottom. Molar mass is always 1 mole. All right, so moles of N2 cancels there, and you end up with grams of N2 as the last man standing. So now you grab your calculator, and you multiply 10.2 times 1 times 28.02 divided by 1 divided by 3. And that gives you 95.3, roughly. I'm not getting at all picky about decimals or significant figures on this. Okay, I want you to just focus on this process, okay? All right, good. Let's go on to the next one. So I'm going to erase here and here. I'm going to use the same flow chart. And it's asking how many liters of N2 gas are produced when 5.3 grams of NH3 gas is produced. So it's saying I'm producing 5.3 grams. That goes down here in the grams row and in the NH3 column. And I want to know liters of N2H4. So that's going to be way up here in the liters row and in the N2H4. Excuse me, NH3. Liters of N2, so I want liters of N2 is what I'm looking for right there. 5.3 grams of NH3, so that's good. So the question mark goes above N2. Okay? So I need a path to get me from what I know to what I don't know. So you go from this box up to this box. This is going to be your translator. That's going to be your conversion. Then I go from this box over to this box. You can only move sideways when you're inside the chemical equation. That is inside the dashed line. And then I go from this box up to here using this translator right here. So it's 3 conversions. All right, so we're going to put way over here on the right is some number of liters of N2. And way over here on the left, we have a lot of space because it's 3 conversions. It's 5.3 grams of NH3. And I'm going to draw 3 boxes if you're so inclined to draw boxes. Okay, and it's going to be some sort of ratio here. Okay, so the first ratio is getting me from grams into moles of NH3, so I use the molar mass. So it's either 17.04 grams of NH3 over 1 mole of NH3, or it's 1 mole of NH3 over 17.04 grams of NH3. Which one do I want on the top and the bottom? Well, I need grams of NH3 to cancel, so I need grams of NH3 on the bottom. So it's 17.04 grams of NH3. And on top, it's a single mole. It's always a molar mass, is always 1 mole. So these two cancel, grams of NH3 cancel out, and I have moles of NH3 on the top there. Okay, so now I got to get from moles of NH3 over to moles of N2. And you can see that's a 4-to-1 relationship. So whatever I have here, I've got to divide that by 4 to get this. If I have 4 times as much of this as this, I'm going to have 4 times as much of this as this. But it's moles of NH3 on the top, so I want the moles of NH3 on the bottom. So that's going to be 4 moles of NH3. And on top, it's going to be 1 mole of N2. So moles of NH3 cancels and cancels. And that leaves me with moles of N2 on the top. Now I'm using my standard conversion for moles to liters of gas. It's always the same no matter what gas. So I have moles of N2 on the top here. I need moles of N2 on the bottom. So it's 1 mole of N2. And on top is 22.4 liters of N2. So moles of N2 cancels and cancels. And you got 22.4. You got liters of N2, which is last man standing. So let's go ahead and multiply. And that's going to be 5.3 times 1 times 1 times 22.4 divided by 1 divided by 4 divided by 17.04, and I get 1.74. Okay, and last up here, how many grams of N2H4 is needed to produce 84.2 grams of NH3? So let me go on back here. So we're dealing grams to grams. Okay, so how many grams of N2H4? So here's N2H4, here's grams, and it's asking how many. That's the question mark. And it's produced, is needed to produce 84.2 grams. So here's grams of NH3, 84.2. So we start here, this is our known. We move up through this molar mass conversion to moles of NH3, from moles of NH3 over to moles of N2H4, and from moles of N2H4 down through this molar mass conversion to grams of N2H4. So way over here on the right is some number of grams of N2H4. And way over here on the right is 84.2 grams of NH3. And it's 3 conversions, right? There's 1 conversion to get to moles. Moles to moles is a second, and moles back out to grams is a third. So we're going to need 3 boxes. Okay. All right. So we have, let's go here. So we have 1 mole of NH3 over 17.404 grams of NH3, or 17.04 grams of NH3 over 1 mole of NH3. Which one do we want? We need grams of NH3 on the bottom, so that's going to be 17.04 grams of NH3. And on top, it's a molar mass, so it's always 1 mole of NH3. All right, so grams of NH3 cancels with grams of NH3. And now we move on. Now we have to go from moles of NH3 to moles of N2H4. And it's a 4-to-3 relationship, but all we need to know is which one do we need on the bottom. We have moles of NH3 up here, so we need moles of NH3 down here. So it's 4 moles, using that number right there, of NH3. And on top, it's 3 moles of N2H4. Okay, moles of NH3 cancels with moles of NH3. And now we have moles of N2H4 on the bottom and grams of N2H4 on the top. That's your molar mass conversion there. So let's go ahead and write 1 mole of N2H4. Molar mass is always 1 mole. And on top is your number of grams for 1 mole. It's 32.06. 32.06 grams of N2H4. So moles of N2H4, moles of N2H4. Last man standing is grams of N2H4. All right, so now you're ready to do the math. So it's 84.2 times 1 times 3 times 32.06 divided by 1 divided by 4 divided by 17.04, and I get 118.8. All right, and that takes care of that one. All right, we're just going to keep rolling here. All right, so in this one, I didn't really leave you a lot of room to do this, so to write boxes. So I'm just going to do it in the condensed space. Because on the AP, they're not going to give you a lot of room for boxes. So grams goes there. This is what I would do if I had this little space: molar mass here, and moles here. And I would still draw my little circle or dash line or whatever around here. It wasn't very good because I want to leave my self space to write here. Okay, and up here I have, if I need it, I have liters, and I have moles per liter. That's the 22.4 liters per mole. Okay. All right, so it's a little bit cramped, but that's the way, it's going to be on tests sometimes. They're not going to give you a lot of space. So how many grams of FES, so here's FES and it's grams, so I'm going to put a question mark right there, are required to produce 9.76 grams of FeCl2, and that's going to be 9.76 right there. Okay, so I'm going to have molar masses for all of these. And what I'm going to do to just save space, I know it's 1 mole per, so I'm going to go ahead and compute those real quickly here. Okay, so we're back. So what I wrote was the number of grams per mole here. So I know to interpret that as 1 mole of FeS equals 87.92 grams of FeS. 1 mole of HCl equals 36.46 grams of HCl, and so forth over here. Okay, so I'm kind of using kind of a shorthand because as you get more experienced, you know what you're doing, and you have to write less and less information. All right, so we're trying to get from here to here. So the question mark is how many grams of FeS? And we start with 9.76 grams of Fe chloride, iron chloride, Cl2. And it's going to be 3 conversions, one from here to here, one from here to here, and one back down through this number to here. So that's 3 in all. Okay, so here goes. We're going to use our first molar mass conversion. It's 1 mole of FeCl2 over 126.75 grams of FeCl2, or 126.75 grams of FeCl2 over 1 mole. So what do I need here? I need grams on the bottom. So it's 126.75 grams FeCl2, and on the top it's a molar mass, so it's always 1 mole. Okay, grams of FeCl2 cancels with grams. Now I'm off to my next conversion. Oh, what did I not do? Okay, I didn't balance the equation. So on the front page, I have this equation. So what I have to do is put the coefficients in that we already came up with. Yeah, I'm kind of doing that on purpose to emphasize the mistake some of you made in class. That was a very understandable mistake. You weren't really warned about it. You can never work with an unbalanced equation. Never, 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 never. The equation has to be balanced before you work with it, okay? All right, so there's the balancing of that equation. Okay, so now we're doing a moles to moles. So we're doing from FeCl 2 to FeS. You notice it's 1 to 1. That makes life a little easier for us. So it's 1 mole, and we need FeCl2 on the bottom. And we need FeS, 1 mole of FeS on the top. Moles of this cancels with moles of that. And now we're ready for our finer molar mass conversion. Again, remember that was a shorthand. 1 mole of FeS over 87.92 grams of FeS, or 87.92 grams of FeS over 1 mole of FeS. We need moles of FeS on the bottom. So it's a molar mass, so it's always 1 mole. And on the top is the grams, 87.92. So moles FeS, everything cancels. Grams FeS is last man standing. So we got 9.76 times 1 times 1 times 87.92 divided by 1 divided by 1 divided by 126.75. And I get 6.77. Or you can call it 6.8. I really don't care at this point. Okay? So we're not worrying about that. We're worrying about this. Okay, there we go. All right, let's keep rolling here. So, again, I don't have a lot to erase. Again, I'm giving you less space on purpose because I want you to see you have to kind of manage how do you do these without drawing all the boxes necessarily. Okay, so here we go. How many moles of FeS? So it's asking us for moles of FeS right there. Here's the moles line right here. And that's a question mark. That's how many of those. Okay, it's required to produce 23.4 grams of H2S. So H2S is way down here, and this is the grams row way down here. So it's 23.4. Okay, so I'm starting at 23.4, and I need to get to the question mark. So I have to go up through this molar mass conversion right here to the number of moles, and then from moles over to moles. So that's a 2 conversion problem. So I'm going to put this, and I'm looking for moles of FeS, and I'm looking for grams of H2S, and it's 2 conversions. That means 2 boxes. All right, and let's go ahead and do this. So I have to go through the molar mass conversion. 1 mole of H2S over 34.09 grams of H2S, or 34.09 grams of H2S over 1 mole of H2S. I need grams on the bottom, so it's 34.09 grams of H2S. Okay, and up on top I have 1 mole of H2S. So grams of H2S cancels there. Okay, now I have to go moles to moles. And this is nice because it's a 1 to 1. So 1 mole of H2S over 1 mole of FeS, or 1 mole of FeS over 1 mole of H2S. I need the mole of H2S on the bottom because I have to cancel with this. So 1 mole H2S and 1 mole FeS. Okay, so mole H2S cancels there and there, and I end up, my final units are moles of FeS. So now I just do my math. So it's 23.4 times 1 divided by 1 divided by 34.09, and that gives us 0.69. 0.69. And that's our final answer there. Okay, one more of these. Hopefully this procedure, I mean, now we've done literally 30, 40 of these when you count the assignment, which was a very long assignment. So hopefully this whole process is starting to, not only are you starting to get it, but you're getting it where you don't have to draw all the boxes, okay? You're starting to see how you can set up these equations, okay? But draw the boxes as long as you need to. All right. how many grams of HCl are required to produce 7.82 grams of FeCl2? Okay, we're going to do the last one. I had a little glitch there, so we're going to do that on a fresh sheet here. So how many grams of HCl? So we're looking for question mark grams of HCl. Here's the grams row down here. Are required to produce 7.82 grams of FeCl2. So I got 7.82 grams right there. All right, so I need to get from my known to my unknown. I have to go up to convert to moles through this molar mass conversion. Again, I'm shorthanding it here, so you're going to learn to do that. I'm not going to write out everything every time, neither will you. Go from moles to moles, and then from moles back out through this molar mass conversion to the question mark. So let's get started over here. And it is grams of HCl that we're trying to find. And it's 3 conversions, so I'm going to write my known over here, 7.82 grams of FeCl2 times, and I have a box here, and I have a box here, and I have a box here. 3 conversions. Okay, so what do we have to do? We have to go from grams to moles. So this is telling me that there's 1 mole of FeCl2 for every 126.75 grams of FeCl2, or 126.75 grams of FeCl2 over 1 mole of FeCl2. I need grams on the bottom to cancel with this, so it's going to be 126.75 grams. And on the top, molar mass is always 1 mole. Cancels and cancels. All right, now I'm going from moles of this to moles of HCl. So I need the moles of FeCl2 on the bottom, so it's 1 mole. Just use the coefficients. That's what you're using for this conversion. And it's 2 moles of HCl. Cancel moles of FeCl2 with that. And now I got 2 moles HCl. Now I have to go from moles of HCl, which is right here, back out to grams using 1 mole of HCl for every 36.46 grams of HCl, or 36.46 grams of HCl for every 1 mole of HCl. So I need moles of HCl on the bottom, so it's 1 mole. And it's 36.46 grams of HCl. So mole of HCl, mole of HCl. And we got grams of HCl as the last man standing, so now I can do the math on this. And it's 7.82 times 1 times 2 times 36.46. Right? Yeah, 46. Divided by 1, divided by 1, divided by 126.75, and that's I'm getting 4.5 grams. Okay, so that's how we do that one.